So this video is also going to be about 9.2 lines of fit. This particular graph shows the relationship between the temperature in degrees Fahrenheit and the number of ice cream cones that would be sold. Um, and while linear models sometimes can be really, really helpful, especially up here where the actual 5 points of data comes from, the table points that are plotted here, sometimes it'll be a little bit inaccurate. At 0 degrees Fahrenheit, probably not. I mean, that's cold. It's way below freezing. Um, Probably not a lot of people buying ice cream cones, and that number is probably more likely zero. And that's a limitation of linear models. However, on this graph, we can see this is 12. And when we get to 20, that number is about probably 40, 42, somewhere in that ballpark. So the y-intercept's really easy. It's 12. It's where the line hits the y-axis, and that's modeling a temperature of 0 degrees Fahrenheit corresponds with about 12 cones of ice cream. And now when we get over to 20, this number is about 42. If we do 42 minus 12, we get about 30. And then 30 divided by 20. If you have more time, you grab a calculator. If you struggle with that, because honestly, I would probably grab one in most cases for slope. But 30 divided by 20 is about 1.5, which is really close to the 1.48, the slope, which is telling us every time the temperature goes up 1 degree Fahrenheit, 1.48 more ice cream cones are expected to be sold. And obviously, that's a rounded number, and you can't tell part of an ice cream cone, but that's what our model's suggesting. So how this plays out in Khan Academy, two things that you should be able to do based off this. First is be able to eyeball the line of best fit. Right now, none of those lines really fit the data particularly well. There's no real association. So that's my guess. Sweet. And if you're not, and then this one, same thing. The orange line fits until about 5. And then the red line fits. It's both positive and negative. It's not really best modeled by a line of best fit. So that's what you would choose. And then the other thing that you'll be asked to do is, all right, here's our line of best fit. What's the equation that models it? Well, it starts at 7.5. And at 1 hour online, the mood rating has dropped to 6.5. At 2 hours, it's dropped to 5.5. So what's it doing? Down 1 mood rating for an hour online. Down 1, down 1. So the equation that models it would be we're subtracting repeatedly. -1 times x, it's the same as negative x. There's a ninja 1 there, or a ninja -1, I guess, and the start value is 7.5. So now I substitute that 5.5 in. -5.5 plus 7.5 is what I'd want to do on a calculator. That's pretty easy mental math to me. It would be 2. And then real quick, just kind of checking up above, 5.5 is a little off the graph, but it makes sense. It should be something below 3. And this is showing the number of adult smokers since 1967. The start value is around 40. All of those have that. So now what's the slope? Well, the number at 10 looks like it's 35. So if I do 35 minus 40, I get -5, and that happened over 10 years. -5 divided by 10 is real close to -0.5. That is probably the slope. And then 1997, how many years past 1967 is that? 30. So I want to plug 30 in. -0.5 times 30. If you struggle with mental math, you grab a calculator, you calculate that. You're going to get -15. -15 plus 40 gives us about 25%. If we go back up and look, hey, at 30 years, the model is suggesting 25% of adults are smokers. Hope this helps. Please give this Khan Academy a try and continue to progress towards your quiz at